Hello, everybody, and welcome back to It's Fundamentalist Fails, and I am Mark Reed. I'll be your host, and today we have a a viewer-inspired one. We had a suggestion through, which I checked it out, and it was a really good idea. So I just want to quickly give a big shout out to Matthias ZG. I'm not sure if that is the correct pronunciation of your username. I apologize if it's not, but they shouted out and said that, hey, you should do carbon 14, and there was a specific request. Give me 1 second. I'm just gonna sort of share with you on the screen the person, which you probably can't see it because I am so not zoomed in. Whoop. Okay, so it was Matthias ZG who said, please do an episode about debunking carbon 14 in Colin Diamond debunks Darwin Long Ages, Dr. Vardaman, I'm sorry. Yeah, so we do have that calamitous one here. So yeah, absolutely, checked it out. It wasn't hard to debunk it. It wasn't difficult. It was kind of, yeah, this is a common one. So hey, love to hear it. I hope you're doing well. It's fantastic. We're going to get into this. Don't forget to like and subscribe. Just for the moment though, I do have to quickly go through that we do have a fundraiser on at the moment. I'm glad I did remember about the fundraiser because I think I forgot a while ago, but basically one of our community members, Miranda, is going through a really hard time. So they are basically in having hospital bills they can't deal with and everything. So it is a really good cause, and if you've given, thank you so much. I really do appreciate you supporting the community. I'm sure Miranda is over the moon at how well it's gone. Look, it just shows that, you know, atheists are not just heartless monsters that don't care about their community, and, you know, they're only out for themselves is the label that we get, and that is absolutely not true. Miranda's fundraiser, I'll just put this in the chat and pin it so we can sort of, you know, if you haven't, if you can spare anything, please do. If you can't, totally understandable. It is really rough at the moment, and I totally get it. But you know, I did give. I'm not doing fantastic at the moment, but I give because I hope that if I was in the same situation, they would do the same for me, and I'm sure she would. That's the thing. I know that particular person would absolutely help out me if I was in trouble. So yeah, thank you so much if you have. I so appreciate it, and hey, I hope that if you're ever in need, if you're ever in the same position that Miranda is, please do reach out, because that is what we are supposed to, that's what we're supposed to do for one another. We're supposed to take care of one another. You know, I wish, you know, have you ever been in that position? You wish you could give to every single charity and everything, you know, that exists. I have often thought that before and gone, yeah, if I do that, I will have zero capital. I will be absolutely destitute, and you know, I don't feel bad about that. Be kind to yourself, right? Like you can't do that because you have to take care of yourself. That's the system that we live in. But that's depressing. That's depressing. Let's go to something that's not depressing. Let's go to something that's just completely joyous, like Young Earth Creationists getting carbon 14 wrong. So carbon 14. Okay, everybody knows it. It basically, well, I mean, you might not know it's 14, but you know carbon dating, right? And so creationists have this habit of saying, oh, they do carbon dating for rocks. No, they don't. Okay, that isn't something that they do. Okay, they do carbon dating. It has to be organic or at some point alive, right? It has to have some sort of exchange with the atmosphere, whether that is a plant or a animal or whatever. Okay, I'm not sure if they explain it or not, but they love to point out things that they think are problems with the carbon dating method. And they think they're problems. What they are limitations, right? So it's not a case that it's a problem that you can't use carbon dating past roughly about 50,000 years. I think the half-life is about 5,700 or so. But it's not a problem, right? It's not. It's just that the accuracy drops to being completely senseless. Like it doesn't. It's just a limitation of the method. They point out you can't use carbon dating, or they point out, oh, we did these seashells or something, and that's a problem. No, it's not a problem. Anything from the ocean acts as a carbon sink, so you'll get like really, really inaccurate results. We can account for this. We can change how we're reading it in order to account for these problems, which are known problems, right? Because we can test them on things that we know the age of. Like, for instance, a ship or something, right? We know when it's built. So if it was built like, 200 years ago, and because of the carbon in the ocean, that's not a very good example because the ship doesn't respirate. But you getting what I'm saying? Like we can account for these problems, but they're not really problems. They're just limitations on the method. It's kind of weird. It's kind of like, sort of trying to debunk forensic testing, because if somebody puts it in a fridge, a corpse in a fridge, it doesn't look as decayed. Like, it's not a problem. We can account for the circumstances of what is happening. But I'm going to get started. But it's great to see you all here. I really feel good about this one because it is a viewer. I'm not sure what I should call you people. Chatter, commenter. It's a commenter suggested one. So I always look. Other people have done suggestions, and if you haven't had a suggestion sort of put on Fundamentalist Fails, look, it's nothing personal. Some of them are too long, right? They're just too long, or they're just too, out there kind of thing, or they're not funny. This one's great. This one was fantastic. It is a bit old. I think it was from like 2013 or something. I really do think so. It was from a while ago, so 2003 maybe? I'm not 100% sure. Let me have a look. But it's important to note who's bringing this information, and there's sort of things that you see all the time in the young Earth creationist circles, and one is having scientists that don't really have their field as the thing that they are talking about. Yeah, so this was from Biblical Tours. It was put up 2020, but I think that it is an old video. It's a very old video. Yeah. And it's kind of a bit weird, but Yes. Dr. Vardaman. Yeah, he's a meteorologist. His degrees are in climate and atmosphere, right? So you may ask, well, what does Dr. Larry Vardaman? Why is he a meteorologist? Astrogeophysics is what he says he's sort of thing. But his PhD is in atmospheric science. Okay, so you might be asking, why is he talking about something that would seem to fall into geology, paleontology, possibly, radio physics, nuclear physics? Why would he be talking about that? Good question. I mean, don't get me wrong; it's tangentially related because. So what happens is that you have basically solar rays come into the atmosphere. A neutron knocks a proton out of nitrogen-14. It's a really easy decay chain. Nitrogen-14 then becomes carbon-14, and carbon-14 is an unstable element, so it will decay over time back into nitrogen-14. Right? That's basically it. So, I mean, it's tangentially related, and he knows how that works, but he's got a problem with dating it for some reason. But, you know, just keep in mind, he is not... The part of his field is not engaged with the actual analysis of the radiometric decay, right? Like he isn't somebody whose field covers the analysis of that decay chain. His field really covers how the carbon-14 is created in the first place. All right?
We're in the midst of a series of shows talking about the work of the RATE group, and Dr. Larry Vardaman is here, and he is the gentleman who coordinated the work of these eminent Christian creation scientists.
Eminent. I think he's making that word do a lot of work. Eminent. They're eminent within their churches, in their sort of young Earth creationist circles. They are not eminent within the actual fields in which they claim to have a degree, or they have a degree. A lot of them do. Look, a lot of them do. Okay, so the RATE group is kind of famous. The RATE group is famous for most notoriously failing to find a solution to the heat problem. So the heat problem, Erica Gutzik-Gibbon did a fantastic video about the heat problem. Basically that the natural radioactive decay of the Earth and other heat-producing phenomenon like tectonic plate stress, like venting from the Earth, volcanoes, it would have created enough heat that if it didn't have time to dissipate, and we do know how fast heat dissipates into space, or, you know, sort of is accounted for, if that happened over 6,000 to 10,000 years, the Earth would be a molten ball of rock. It would just be pure, like the heat generated is ridiculous. And so this group, this RATE problem, was the creationist answer to, well, how do we figure out how to account for all that heat over 2,000 years instead of 4 point whatever billion years, right? Because if you have that amount of time, the heat then dissipates. So the RATE problem, the heat problem was one that the RATE looked at in all these different ways, came up with every explanation under the sun. None of them worked, and then eventually they had to sort of say, well, we have. I mean, I hesitate to use it. We have faith they're going to find an answer to this in the future, which, like, it isn't necessarily, oh well, they're wrong, but just the amount of resources they threw into this to avoid coming to the conclusion that their 6,000 to 10,000 years has to be wrong is incredible. Like, they really tried any other explanation. It's really funny because Standing for Truth, big call out to Dodgy Donny Deals. He sort of has people on all the time, too many times, saying they've solved the heat problem when they've done nothing of the sort. But these guys basically could not solve the problem. The easy answer is that the Earth is not 6,000 to 10,000 years old. Last I heard, there was a geologist. He passed away, unfortunately, but because it would have been great to see his work. But there was a geologist, David McQueen, who was looking for a way to rewrite physics so it would work. And as far as I know, they didn't solve that problem. But yeah, this is the RATE group, and that's their claim to fame, is their failure to solve a very, very difficult problem in young Earth creationism.
Who pulled together their work to work on the age of the Earth.
Right. The RATE project is radioisotopes in the age of the Earth, and I was kind of the organizer of it and the administrator.
So you pulled together these 8.
Yeah, so we know of all these elements of decay. You've got, certain uranium types of decay. You've got carbon that decays. You've got all of these decays. Upon decaying, these unstable elements will throw out an alpha or a beta particle, right? Every single time it decays or a particle decays, it will throw out energy. So this decay will produce heat, and a lot of it, right? Now, with the timeline that the geologists have, it's not a problem. That heat, it dissipates into space. It gets spread out over the Earth. It gets redistributed. It's fine. But a young Earth cannot account for the heat that's being generated. So, if anybody has solved the heat problem, well, you don't have to. Donnie's solved it multiple times, in fact, in different ways, apparently.
Really A-team players from creation science.
That's
and,
right.
And you worked for 8 years together, and you came up with 3 incredible conclusions that seem to indicate a young Earth. Would you list those for us?
Sure. We've talked about helium diffusion in a previous program.
Yeah, so helium diffusion isn't really a thing. There's multiple reasons why helium diffusion is kind of not a thing. I think I had one article here on how sort of they put out a paper sort of for old Earth diffusion model. And they sort of get the rates of diffusion really, really wrong, really terribly wrong. There's some reasons why it shouldn't be sort of looked at. The technical literature did not report any evidence of the loosely bound helium remaining past the first temperature ramp. So these are a list of the rate helium diffusion project things that they've put out. A book which has the forum was closed. The American Geophysical Union was open, non-creationist. Presented a 350-word abstract with a poster. The conference is held once every 4 to 5 years for this one, and sort of the only time they've published it was in the Institute for Creation Research and the Creation Research Society, and it was privately published. They haven't really given any reason why we should trust this model that they've shown. Right. So this graph, for instance, is a predictions of the 2000 helium diffusion model measured to actual data, and you can see that they kind of are way off. Their predictions don't happen. So this went into a whole spiel, a whole breakdown of why their predictions are so terrible on helium diffusion. It's not a thing that is accurate. And the fact that they don't peer review it means that they never have to go up against that scrutiny. So polonium halos is sort of another one that they sort of say, hey, all of these halos are made by polonium. We don't know that for sure. But yeah, he just briefly mentions them. So I won't go deep into them. I don't want to go deep into them, but there are sort of responses to this kind of thing of why these things are not polonium, and it's kind of I tell you what that you hear. I will go into a article that was put out by Robert V. Gentry. And it basically has a number of questions here that really represent the problems. Do the rocks from which Gentry drew his samples represent the primordial basement rocks of the originally created Earth? Because what they're doing is they're getting rocks, right? Like, for instance, they're getting metamorphic rocks or volcanic rocks. They're getting rocks that are basically transformed, and they're saying, okay, well, these rocks are old as the Earth, basically. But we don't know that, because when some chemical processes happen, igneous rocks, I don't know why I couldn't remember that, the igneous or metamorphic rocks, when some processes happen, that's when the rock is dated from. Right, like when these sort of processes happen, like especially for an igneous rock, like you can't just say, well, the rock was there since the beginning of the Earth, so that's the age of the Earth. No, new rock is formed, right? Like new elements are added to the rock. So, these rocks, they don't necessarily represent old rock structures. Are the concentric halos observed by Gentry actually caused by alpha particle damage to the host crystal structure? If the concentric halos are indeed caused by alpha radiation damage, is polonium decay the only possible cause? Is Gentry's hypothesis consistent with, or does it explain all other evidence pointing to a great age for the Earth? So those are the questions that the guy would have for them, but of course they're not putting this into peer review. Yeah, thanks, Al. Thanks, Al. You got me, mate. You got me. Thank you. I don't know why that absolutely threw me. That's weird. I must be getting old.
We've talked about polonium radio halos, and today we're going to talk about carbon-14 and coal and diamonds. And these are just three premier examples of accelerated decay and evidence for a young Earth.
Okay, so the problem with... So he's already done a misstep, right? Like, the whole idea of carbon dating is that you do it for living things or organic material, right? Like, you can't do carbon-14 dating on rocks. Okay, you can't do it. Okay, so this is one of their things that they put out. Accelerated decay is in direct opposition to the main assumption of radiometric dating in the evolutionary scientific establishment. It's not really evolutionary, it's just geological. It doesn't really have much to do with evolution at all. It's just that's their big cross to bear, right? That's their main hatred is evolution. So they're going to tie it back to evolution that they want to. It's really just standard geology, though, which is that the radioactive decay rates are consistent with time. Yes, they are consistent with time. We can base nuclear clocks on the decay rate of some of these elements. Like, it is constant with time. That has been absolutely established. To sort of go back now and say, well, it might have been different in the past, I don't understand. We have tested this with things that we do know the date it was around, right? If you have a scroll saying, hey, this has been penned in, this time, right? Like this has been penned, and that scroll is made out of papyrus, for instance, and that papyrus was cut, like, we know the age of that, and then we can test to see if that paper, when dated, gives us accuracy, and it keeps doing so. Like, this is a bit ridiculous. It's sort of going, well, it's sort of like, what's a good example? It's sort of like a doctor saying, if you give this medicine, it will help with this symptom of this disease, kind of thing, right? He's saying, hey, every time we give this thing, we've tested it, every time we give this thing, it helps with this symptom. And then them coming along and saying, no, we're in opposition to that. No reason, just opposition. Because, for some reason, not testing it, not showing that results are off. No, just basically saying we're in opposition to it. Because it has to be. Because reasons, apparently. Because
I think this term accelerated decay is going to be to the next 10 years what perhaps irreducible complexity was to the last 10 years in this whole debate.
I freaking hope not, because, I mean, if you mean a made-up sort of technical term that really holds no weight and gets shot down in court, then maybe. But, you think that is somehow a smoking gun, but it's not. Irreducible complexity is not a thing. It's just something that they made up, so... they want to say, well, irreducible complexity is a thing, and if it's a thing, then your science can't be right, without actually debunking the science.
So even more.
I think that's really exciting. Well, today we're going to talk about carbon-14 dating. Now, I think for most of our folks, people think that carbon-14 is what's used to date everything, but it's not really what's always used in this whole dating scheme.
No, it shouldn't be used to date everything. It's got limitations. Those limitations are not excuses. It's not like this problem with the method. It's just things that we're aware that it has limitations. And that the reason why is because we've done extensive testing on it. Like, very extensive testing. So there's a couple of things. It does have a maximum age as I said, I think it's about 50,000 years. You can't go any further back. So you get these people, these idiots saying, oh, we measured this dinosaur bone and, we carbon dated it and it came out to 50,000 years. Yeah, that's the maximum. You can't, there won't be enough carbon to test after that. Except there can be trace amounts due to contamination of the sample. We'll get into that later, but just be aware that in carbon-14 dating, there's always a background level in any given sample, and there's very, very good reasons for that. So this is a limitation of carbon-14 dating, but instead of being understanding and being aware of these limitations, instead they just ignore it and keep just arguing it doesn't work because the methodology of doing it has limitations. That doesn't make it incorrect. It just means it has limitations. We're aware of them. We can account for them. We can recalibrate for them. It's not a problem, but they seem to think it is.
No, carbon-14 is used for dating organisms that have died or some type of a life process. Carbon-14 has a half-life. That means half of the radioactive material in it has died away within 5,700 years. So only a few lifetimes, it's all gone.
Yeah, so atmospheric scientist. Yes, I understand that. You should be aware of the particles in the air that has been hit by sort of solar rays and has basically been transformed from nitrogen-14 to carbon-14. You should be very aware that as we exchange that with the atmosphere, we get part of that trapped within our bodies. Oh, it's a raid? Oh, welcome. Thank you, Dr. Kip. Welcome. We're talking about carbon-14 and why young Earth creationists do not understand it. A Hebrew raid, is that any worse than a normal raid? I don't know. So yeah, I mean that is yeah, absolutely. Thank you. I really appreciate it. So we exchange this with the atmosphere, and that's completely normal. Carbon-14 is unstable, so in the living creature's body, when you go to test it, the older it is, the more as a ratio, the more carbon-14 to non-carbon-14 there will be. Now there's some limitations, as I said. Because the half-life, which is the half, this is the thing, they say that, oh, we're challenging that it's reliable and it is a reliable way and a reliable decay rate, right? Like a reliable clock rate of that half-life, while they're very aware that in every single scenario that we have ever tested with half-lives of radioactive material, you can set your watch by it. We do set watches by it. We have atomic clocks that they measure the decay rate and they can give you timing based upon, and it is uncannily accurate. So after about 5,700 years, half of that carbon-14 will have undergone radioactive decay, and it will be sort of, nitrogen-14. Okay, so that's basically how it works.
Because to date rocks, you have to use such things as uranium, lead, or rubidium, strontium, other long period half-life materials if you're going to date.
You mean rocks like diamonds? Like diamonds? Yeah, so the question is, well, how did the diamond get carbon-14 in it? And the simple answer is, it's not the diamond that you're measuring the carbon-14 in. I will sort of go more into that.
Rocks.
So, but carbon-14 then, if we're studying rocks in the age of the Earth, how does that come into play?
Well, carbon-14 relates specifically to fossils and wood and anything that was alive in the past, which we want to get some handle on when it died and how long it's been around on the Earth.
But you're going to apply this to rocks, aren't you? Particularly to coal and diamonds. I'm kind of
I feel like this interviewer is a fake skeptic. Like, oh, but you're going to apply it to diamonds, aren't you? Yeah, you already know that he's got an answer for this. I feel like he's being, the devil's advocate, literally.
Giving away the story here, but
coal and diamonds are a type of rock, but they have carbon in them.
Yes.
And particularly coal is made up of a material that was compressed, I believe, during the flood. And so we can actually get an estimate of when the flood occurred based upon how old the coal is.
well, we're anxious.
Yeah, we can't tell how old the coal is, because the only way that carbon-14 dating works is that an organism respirates in some way, right? Like they respirate and they have an exchange with the air, and particles of C14 that have been hit by solar rays come into their system. That is how it happens. Rocks famously do not respirate. Okay, they don't. So you may be asking, well, how did it get there? And the answer is contamination. And that contamination comes from all kinds of things. One of the things that it can be contaminated with is bacteria. And I'll go sort of more into it. But usually what they are picking up is bits of bacteria, or just individual cells of bacteria that have C14 in them, because the levels are so low. But they want to say, oh, it's got trace amounts, it must not work. Like, I don't care how cautious you are, how clean your rooms are and everything, you can still get trace amounts from microorganisms within rocks. And we're aware of this, right? Like, nobody is confused by any of this. That's just what happens. So, what they're measuring is these tiny little amounts from various bits and pieces of rocks. And you might go, okay, well, what if why do they have it all, sort of everywhere? They don't. Some parts are sealed away, some are not. So what happens is that if you take tiny little samples from all over the part, your sample size is really small, like you're only getting tiny little bits everywhere, right? You will run into parts with sort of 0 carbon-14 and sort of a little bit trace amounts, right? That's if you take a really big sample of the rock, like if you take a huge sample of the rock, you will get basically some parts that have been contaminated by microorganisms, but it'll be just a background level. It'll be such a trace amount. So the key here is to understand that in order to correctly date a rock, you have to take large samples. Guess what the creationists don't do? They take very, very small samples and say, aha, that tiny sample had some carbon in it. Carbon dating doesn't work. Why? I don't know. It seems bewildering.
Just to see what you have to share with us today, because I think this is a program that has evidence that's almost irrefutable.
Almost. Really? You think so? Almost, but not quite. Evidence that's almost irrefutable is still refutable. I'm sorry. It's literally the case. I'm sorry.
One of the first things that we like to talk about is bones. This is a picture from the National Dinosaur Museum in Utah, Vernal, Utah, and we can actually try to date those directly by doing carbon-14 techniques.
Yeah, so carbon-14, like, why would you be doing it on bones that you know are older than that? I suppose you don't. But, that's not going to give you a accurate response, because they're outside the range that we're looking for. Okay, you can do it, but it's not going to fall to 0 carbon-14. There's always going to be that background noise
on them. Another thing that we can do is coal, but this hasn't been really addressed very much, at least in the conventional literature, because it's assumed that coal is like 100 million years old. And since carbon-14 has a half-life of about 5,000, almost 6,000 years,
Yep.
If coal is really 100 million years old, you wouldn't expect to find any carbon-14 at all in it.
0, that's right.
No, not true. This is where they're going wrong, right? This is where they're going wrong, due to the way that microorganisms get into things. That sample, if your sample size is too small, you might. Well, I mean, it's not even if the sample size is small. You will have, due to contamination, right? That's what we're talking about, is contamination. It's not the original sort of a tree that undergoes the transformation into coal. It's not that, right? It is a you're picking up carbon-14 from microorganisms that have contaminated the sample. And so when you look at the sample in whole, there should be a small amount of background noise to it, of carbon, basically. It never falls to exactly zero. But what should happen when you're doing correct carbon sampling is that you should be able to take a large sample and the carbon should be almost negligible, right? Because there's not, like, in comparison to the amount of nitrogen 14 in the substance, there's not that much carbon 14 from microorganisms. It just isn't. So it's kind of really dumb that you think this will work.
Zero. In fact, the bones that we showed in the previous slide, the dinosaur bones, those are assumed to be 65 million years old or older. So you wouldn't expect to find any carbon-14 in them either. But we're going to talk about that a little.
Yeah, which you don't find it from the bones, because if it was carbon-14 that was respirated in from the atmosphere and diffused, it would be all throughout it in a very sort of a very consistent way. But what we aren't talking about that. We're talking about you guys taking samples, finding some of those samples have trace elements of C14. They are your contaminated samples. And we don't mean that like when you say contaminated samples, people often assume that you're talking about, oh, they got the bone out of the ground and, you know, in the process of taking the sample, you shed hair into it, or you in some way upset the sample. No, it could have been contaminated by microorganisms a million years before you got to it, right? Like, we're not saying that, hey, though that contamination happens on site when you're digging it up, right? But that's what you think of. Oh, the scientists screwed up, they contaminated the sample, but that's not what it means. It just means some foreign body to that organism has gotten into it. And that happens all the time with microorganisms.
A little bit here, because in fact we have been finding carbon-14 in these, surprisingly. There is a new instrument that has been developed. It's called an accelerator mass spectrometer. And this was developed about 15 years ago, or a little bit more now. Prior to that, the instrumentation that was used to try to measure carbon-14 in objects, any kind of material, didn't have the precision to be able to find the small amounts of carbon-14 that are still present in coal and dinosaur bones, for example.
Yeah, because they're tiny. They're tiny amounts, but we know where they're coming from. So this is what the scientists say, that in any large sample, you should have, even if it is billions of years old, there should be some background level of C14 that is almost negligible. It's almost nothing, right? But there will be there. And that is just, you cannot avoid picking up the bacteria that sort of get into every sample. But on a large enough sample, it should be almost nothing. So we can account for this, right? This isn't a problem. It's just a limitation of the method. And we can account for that limitation. And we can calibrate our data based upon things that we know the age of and how the system works. Like, we know how to, like, calibrate for that. It's like sort of saying, hey, whenever you're measuring something, you put your butter in a container, you go to measure it, and the bowl is adding weight, so it can't possibly, like whatever you put the butter in whatever bowl you're keeping in it to measure it, it adds weight, so it can't possibly be accurate. No, it just requires a recalibration. We just put the bowl on first and tear it. Like we take that off, and then it's perfectly fine. It's perfectly accurate. We know how to deal with this background noise, and the background noise, we know why it occurs. We know what we should expect from it, and we know how to deal with it. And can I just point out, even if dinosaurs are like 50,000 years old, like the maximum that carbon dating can do, it's still way higher than the 6,000 to 10,000 years these guys are saying. Like, it's still way higher. What they want to do is just say, hey, there's a problem with this method when there is no problem. There's no problem with carbon-14 dating. It's not a problem, right? And then say, well, because there's a problem, you can't use it, it's all inaccurate, throw all the data out kind of thing. That is ridiculous. Number one, it is accurate if you take into account the circumstances on which you're doing your sample, the methodology that you're doing your sample. It's totally fine, right? Like I said, it's like having a forensic team have a body that's been cooled, so they have to expect different time frames. They can account for that cooling. It's not a problem. It's just a limitation, right? Like, you can't just throw out forensics because you have to account for certain circumstances. It's silly. It's silly.
But about 15 years ago, this instrument was developed, and unbeknownst to us, when we started the rate project, there was reports already occurring in the conventional literature. So after we started our rate project, we were informed of this, and we added this effort to our program.
Yeah, so by the time Larry here has gotten to the machine, the secular scientist, the mainstream science, has already picked up the carbon, wondered why it's there, found the reason why it's there, and then accounted for it. But they just ignore all of the work done to find out the answers to the questions and just focus on the problem that isn't really a problem.
Because it was so significant. And in fact, there was some 70 papers that were present in the literature reporting on carbon-14 in coal.
Yes.
Now, we were completely surprised by this. We didn't.
I don't know why. I don't know why. This is sort of this is how science works. What we don't do, these scientists use the machine, as you called it, the instrument for measuring C14. They observed something that didn't fit, and they actually went out and found out why it was occurring. But you want to ignore all of that and just go, well, the problem exists, when it doesn't anymore, because we found out why it was occurring, right? And then say, well, because the problem existed, I just don't accept the solution. It's wild, right? It's wild.
Know what had been done. And the question is, if there were so many papers in the literature, why hasn't this been widely known and accepted?
It is widely known. It's very widely known. This is there are limitations with carbon-14 dating. This is one of the things they teach students, because this man would not have gone through the actual dating process in university, right? Like, he's an atmospheric scientist. I don't know why carbon-14 dating in fossils would be one of the things that he would go through. But this is taught to people who date them because they have to know. It's not surprising to them. But what they found is that if you take if you take very small samples, you might hit a part that has a sort of a statistically significant amount of C14 in it. Something that throws it off. Like, basically you've hit a bunch of microorganisms that are younger than the bone when it died, than the organism when it died, right? Like, and that might throw off your readings. So ideally what they do is they get large samples, and it basically, on average, will reset to negligible. Now, when the a rate project, and the creation scientists did their samples, one of the things noted is they were getting extremely small samples. And there was also, they pointed out that they basically dropped the samples that had sort of none in whatsoever. They only focused on the samples that have a larger than average C14 still there. So they're cherry picking, essentially. And all of this has been pointed out. This would have been pointed out during peer review, but of course none of these people put up their arguments for peer review, right? Going through the literature of this rate project, it has never been subject to peer review, ever.
So before this machine, we didn't have an instrument precise enough to measure the carbon-14 in coal. Is that right?
That's right. There had been a few creationists who had tried to develop equipment to do that, but it just wasn't.
Yeah, you're right, Jason. Yeah, some people are sort of saying when this is from. It was posted in 2020, but yeah, it probably is from the 1990s, maybe late 1990s. I think the original, when they used it, was about 2003 or something, but I wouldn't be surprised if it was an older video still. If you're wondering why I'm doing such an old video, it was requested by somebody, and I thought it was really interesting. I'm not even sure if they use this argument anymore. I think they do. I think they still use this argument, even though, like, to say debunked is just an understatement. Like, this has been absolutely thrown out. Like, this is the most nonsensical thing. I don't know if they still use it. They shouldn't do. They shouldn't do.
Wasn't precise enough to measure those small quantities.
And the results of this instrument are accepted across the board by all scientists.
Yes, and the reason actually that it's reported so widely in the literature is when they first began to get measurements of carbon-14 in coal, they were scratching their heads and say this can't be because the coal is too old for there to be any there. Where did it come from? So they assumed it either had to be contamination of the coal, carbon-14.
Yep, that's it. That's it. You got it. You got it. But contamination doesn't mean the scientists contaminated. It means that there are microorganisms in the fossil that are throwing off your data. You're picking up a tiny amount of C14 because they don't they don't take in a lot of C14, but it's enough for something very sensitive to notice it. That's it. He's got it. By gad, he's got it.
14 from the atmosphere had gotten into the coal somehow and continued to do so.
No, it's not somehow. It's not somehow. Technically there could be like a crack or some kind of thing, but usually it is like bacteria kind of get everywhere, right? It's really hard to keep a sterile environment, really hard to do. And when you're working out in the field, that is not a sterile environment, my guy. Now, there isn't really any way to sterilize bacteria from a bone and still have it usable and testable. I don't know why this guy doesn't understand this. It's wild, right? Like, what are you talking about? The contamination is it. Contamination of the sample. That is it. That's it. He's got it.
So, or their instrument itself was somehow being contaminated. So they kept reporting on it and refining their instrumentation. A little bit of it was due to that, but they finally eliminated all those possibilities and they were still getting the carbon-14 in the coal.
That's exciting. So you made that
That is not really exciting. It's taught in class every day and people are bored. You know what the scientists contaminated Mars? Yeah, it's very likely that they did send, we have contaminated Mars with microorganisms that just came through on the rover or on whatever. Very, very likely. Very likely. What effect that will have? I don't know. Will that bacteria even survive? I don't know. But bacteria seem to be capable of surviving very, very well everywhere. So it wouldn't surprise me if that bacteria took hold of Mars. Look, there's bacteria, I don't remember the name of it, but it lives on the inside of nuclear reactors. And yes, its DNA gets blasted apart by radiation all the time, and it kind of just repairs its own DNA. It's actually quite insane. Bacteria, I was sort of having this argument who people said, like somebody sort of saying, hey, humans are the masters of this world, we are the greatest thing on it. And I'm like, well, actually, bacteria kind of have us beat. In fact, we need bacteria in our gut to survive, at all. So when you sort of say humans are the masters of this world, the apex, type of life form, no, bacteria are everywhere and they kind of have us beat. Because, in fact, we need bacteria to live. So are we the masters if we need bacteria and bacteria don't need us? I don't know about that one, Chief, but hey.
Part of your project.
Yes, when we discovered this, we included that as a major part of our project, and
Well, I do notice that, yeah, Jake, it might be. We don't know. It might be that, hey, we might just, we don't know. I mean, it may be that bacteria get to other worlds by, collision events or something and carry bacteria across space, because there's bacteria can survive in space. Some bacteria can easily, they just shut down their functions and they just reanimate. Some bacteria that went into space with the astronauts on the space, they just reanimate. It's actually quite fascinating. Bacteria are hardy in a way that is extreme, but it might be an issue, or we just might have sped up panspermia by a few million years or something. We don't know. This might be a relatively common event galactically, as part of, might happen all the time. It might never, we don't know. I do know also that the samples were contaminated by scientists that came from Mars. They sort of thought that we had found life on Mars before realizing, it's an Earth bacteria that probably stowed away and we screwed it up. So that did happen as well. It wasn't the only Mars-associated contamination event, which is kind of hilarious. Left-handed Jedi for $20 US. Thank you, Jedi. Red Rover, send Spirit on over. Yeah. So what? There's Spirit, Curiosity. I can't remember the other rover's name. Pathfinder? Wasn't there Pathfinder? Oh, that was the landing craft, I think. What should the Mars rover be called? I want to know. What should it be called? Just quick Google says they were Sojourner, Spirit, Opportunity, Curiosity, and Perseverance. Oh, look. The rover is amazing. Oh, and there was Zhurong as well, which is the Chinese rover. That's cool. We always forget about the Chinese and, Indian rovers and stuff. Like, seriously, we really have to acknowledge that they are doing work as well. I think that's only fair. Yeah, Curiosity was just like it absolutely blew out of the water. It's still going, and it should have, died ages ago. It's such a little trooper. Such a little trooper. Yeah, what a thing. I think Curiosity was probably my favorite, just because, they absolutely should have packed it in by now, and it's still going. Awesome.
the end result of this was a significant evidence for a young Earth, we felt.
Okay,
well, that was the instrumentation.
Yeah, that is not significant evidence for young Earth. But thanks, Jedi. I really appreciate it, mate. Yeah, the Mars rovers. That's awesome. I don't know. I really like, I really like Voyager 2. We shot it into space, and it's still just going as it sort of hurtles away from us. Just quietly doing its job. I don't know. Maybe anthropomorphizing these probes and these probing devices. But hey, it's fine.
That we had. Let me tell you a little bit about where the carbon-14 comes from in the atmosphere. Cosmic radiation.
Yeah, Voyager 1 isn't. I think Voyager 1 died, but Voyager 2 is still going strong. Yeah. Yep. Voyager 2 is a... So the problem the problem people have with Voyager 2 is it contains a gold plate, which in sort of an IKEA diagram way tells anybody that finds it a bit about humans, our anatomy, and our location within the Milky Way, within the galaxy. Now, a lot of people have pointed out that if there is hostile organisms out there, that is probably a bad idea. I do like the optimism of it. I think that somebody sort of said, hey, I don't necessarily think that all organisms are hostile. In order to get to the point of being spacefaring, you probably need to be cooperative. And why wouldn't that cooperation extend to other species? And I'm in two minds about it. I think that humans can be cooperative and do great things, and they're still very tribalistic. I don't think one automatically negates the other. So, yeah, I'm in two minds about it. But I do, it was more optimistic time, I think. I think it was a time of, well, the challenges of this universe are so harsh, we should we should team up with everybody we can find. And you would hope that an enlightened species would realize that cooperation is better than aggression. But some people think it's not. I don't know. I don't know with that one. I don't know.
Comes in from outer space and strikes nitrogen-14, and it converts it to carbon-14. One of the atoms becomes carbon-14, and it's distributed among all the other gases in the atmosphere. The assumption in carbon-14 dating is that has been going on ever since the Earth has been here, and it is.
Yeah, it has. It has been going on ever since. But why wouldn't it? If nitrogen is in the atmosphere and the same solar radiation is coming in, why wouldn't it? I don't understand.
Same rate, so that the amount of carbon-14 is uniform in our atmosphere. That's a major assumption of this process. Now, it turns out I don't believe that was the case, but it's still the technique that we have to address.
But why isn't that the case? Why wouldn't the atmosphere? So there's a few things that sort of young Earth creationists try and say, oh, but you don't know how much, because here's the thing. We know that the amount of C14 you will have in your system is the same amount as the atmosphere. And this is why he's sort of pointing to the atmosphere. He's not just that that's his field, and he's sort of going outside of it talking about radiometric dating, but never mind. Like the amount of C14 in your body will be essentially the same as the amount in the atmosphere, right? It just diffuses throughout your body. You basically get the same amount as what is in the atmosphere. Okay, so he's sort of saying we have no reason to think that cosmic rays would have turned nitrogen-14 into carbon-14 in the past. Why not? That is what happens. As long as there was nitrogen in the atmosphere and there was the same solar radiation, which you would expect there to be, that should be the same process. Like, why wouldn't that process happen? And respiration's the same. Why, over the last 50,000 years, breathing hasn't changed much. Just saying. Why wouldn't you expect it to be the same? Well, a lot of the time they point to, well, you don't know how much C14 was in the atmosphere, right, in the past. Okay, you don't know, was there much less C14 in the past or much more C14 in the past than there was today? You don't know. Were you there? It's like, no, I wasn't there, but the air trapped in bubbles in ice core samples was there. Like, just because we weren't there doesn't mean we can't test the air, right? Because what happens is that when the ice forms, especially, and this is only on permanent glaciers, the air gets trapped in bubbles. Those bubbles, when they do an ice core sample, Antarctica, the reason why a lot of teams are down there is ice core samples. They will take a sample and little bubbles of air will be trapped in there. We can test that to see what the atmosphere was. I think the latest one was sort of 1-point-something million years, because the ice core samples, from the summer and winter, even in Antarctica, will have a band on it. It basically during the when the sun's out during summer, it will melt part of the ice, and then it will the winter will freeze it again, making this banding shape to it, and it gets compacted, and that forms an ice core sample. So we can actually date these really well. Even something like dendrochronology, right? Like we can count tree rings back. Okay, so these trees, we know what age they are. So if we know when, say, a logging event happened or a tree was cut down, right, we can count the tree rings back and know, oh, the tree was this old. Carbon date it and see that it's accurate. We've got a physical timeline. And what I think Canada has a really good example of this. What they can do from the width of the tree rings is actually line them up, like one tree after another, to make a timeline going back. Like they can actually line the trees up, so sort of one only goes to this time, but the next one carries on, and they can line the tree rings up to find out, like, because it makes a pattern depending on, you know, how many storms or whatever, you know, what amount of oxygen was available, the amount of sunlight the trees got, so they can actually like line up the trees so they make an ongoing calendar of the years, and we can date them, and it is extraordinarily accurate. That's the thing. We don't just rely on, well, this has got to be accurate. That's a really good analysis, Jason, like overlapping barcodes. Yeah, it's actually really fascinating. The dendrochronology is fantastic, like, because it gives us a alternative dating method that just perfectly aligns with the radiometric dating that we're doing. It's actually really cool. But, you know, we do know the amount of atmospheric carbon-14 there is because we have ice core samples. Really fascinating stuff. I found ice core samples just absolutely fascinating. It's incredible. They even see the band of darkening ice in Antarctica from the Industrial Revolution, from all of the coal and soot and stuff being pumped into the atmosphere. It's actually fascinating. There is a darkened band where that Industrial Revolution happened. Really fascinating.
There's also this carbon-14 that has been produced by cosmic radiation is then incorporated into living organisms. For example, plants, cows and other animals that eat the plants.
Yes, thank you. We know what living organisms are. Thank you. I keep thinking, man, he doesn't have to explain all of this, but you know, maybe he does. Maybe his audience isn't aware that a cow is a living organism. I don't know.
Other animals like mankind that eats the cows, embedded in those living organisms is the same balance of carbon-14 and carbon-12 that is present in the atmosphere. When that organism dies, it's no longer incorporating any carbon-14 from the atmosphere, and what's in the organism then decays. And so by measuring the amount of carbon-14 and the carbon-12 in the organism, you can estimate how long it's been dead, how long ago that organism died, whether it's an animal, whether it's a plant, a tree, or a dinosaur, whatever. So you can get an estimate. Now, it's based on the assumption that the carbon-14 and carbon-12 ratio in the atmosphere has always been the same.
No, that's not an assumption. We've got bubbles of air that have been trapped in ice since that time. We can actually measure. It's not based upon that. That has been confirmed. We know that is the case. It's not a guess. It's not an estimate. It's not a thing. It is down to being able to actually test that atmosphere. Sorry.
And as I say, I don't believe that was the case, but that's the technique. Now, how does this apply to trying to estimate, for example, the age of coal and maybe the age of how long ago it's been since the flood?
So your assumption is there's been this global flood. That's the problem. Because don't forget, he thinks that all of this dates back to the flood. It's all just flood geology. That's not a thing. It's not a thing. Okay, it's not a science. It is a apologist tactic for basically undermining the science. They will find any of what they think is a problem and misconstrue it in order to say, hey, it can't possibly be right. Even if carbon dating puts a piece of coal at 50,000 years. Now, we know that's inaccurate. There's other dating methods you use for rocks, okay, and other things. Like you don't use carbon-14 for inorganic materials, because what you will pick up is simply contamination from microorganisms. That's all you're going to pick up. That's it, right? Because the coal never respirated. It never brought in air in the first place. Okay, so don't forget, it's got to respirate at some point. It doesn't. Okay, so that is ridiculous. That's stupid. Because what carbon-14 dating, it isn't telling us like how old the sample is, right? Like it's not telling us, this is an organism that was born 20,000 years ago. That's not what it's doing. What it's telling us is when it died, right? When it stopped accumulating carbon-14. It's telling us when it died. So you can't apply to a piece of coal, when did it die? Okay, you can't. That's silly. I mean, I suppose so if it was a tree or something, but the process that coal has undergone from being, the wood into carbon is, it's ridiculous. Like why would you date a diamond, a piece of rock, for when it died? It didn't die at any time. What you're picking up is the dead microorganisms inside of it. That's what you're picking up.
This is an animation showing the carbon-14 and the carbon-12 in the atmosphere being incorporated in a tree, for example. This tree then suddenly being buried by the flood, and all this organic material being buried, grasses and trees and ferns and all that material, into a layer compressed by heavy pressure, forming coal. And then within that coal is that same carbon-12 and carbon-14 that was in the tree to start with, but it was suddenly buried and killed. And then the carbon-14 decays into carbon-12. And
yeah, so trees don't just turn into coal, right? That isn't what happens. They need to be cooked. They need to have high pressure and heat in order to become coal. It doesn't just, the whole idea that a tree is buried and compressed for 6,000 years and it just becomes coal, that's kind of laughable. Like, that doesn't happen. It's kind of similar to the way that oil is made, but basically it's tree and organic plant matter that has been compressed, but because of the way tectonic plates move and they subduct and they're pushed under one another, it's cooked near the mantle at very, very high heat, and that makes the coal. Very similar to oil. Oil is basically algae. It's algae that used to be in this massive ocean of algae, and it was pushed. All of those creatures died. All of those plant creatures died. It basically got pushed underneath due to tectonic forces, and the mantle, the hot part of the earth, cooked it into this oil. And that massive ocean of algae is where the Middle East now is, which is why they have ridiculous amounts of oil. I think Donald Trump said that America is like producing more oil than Saudi Arabia these days. It was the most ridiculous, laughable comment. Like, seriously, no, absolutely. That is a 2-second fact check, seriously.
You can estimate how long that coal has been around. So if we were to date it using the conventional technique, we would expect, if the flood only happened, say, 4,000 or 5,000 years ago, you would expect to still find some carbon-14.
But if it...
Yes, but you don't find, like, if it happened 4,000 or 5,000 years ago, you should expect to find over half the C14 of the atmosphere. right? Don't forget, C14 has a 5,700 roughly year half-life. So in 5,700 years, you should still have half. That's C14 still there. You should have half of it. But you don't. You have a tiny trace amount. Okay? A tiniest amount. So why is that? That's what I'm saying. Even if this tiny little amount, this trace amount, means that it is at the older limitation of C14 dating, it should be 50,000 odd years, 50, 60,000, not 4,005. You're off by a factor of 10.
Happened millions of years ago, there wouldn't be any carbon-14.
That's right. If it happened 100 million years ago, which is the standard expectation for a coal layer, it's that old, you wouldn't expect to find any carbon-14 at all. So what happens when you go to the field and collect coal samples and analyze it in this new equipment that has this precise ability to measure carbon-14? It estimates the coal to be about 50,000 years old.
Yeah, 50,000 years old. Well, it doesn't. It's just you're picking up on some contamination from microbacteria. That's I've already explained that twice, but these guys just want to ignore that. But even if that wasn't the case, you're still out by a factor of 10 for your flood, right? You say 4,000 to 5,000 years old and it's giving 50,000. You're still wrong. That's the thing. But they don't acknowledge that. They just say, oh, it has to be wrong, so flood then happened. Well, hang on a second. How do you account for it not having half the C14 still there? How do you account for that? Well, then they go to, well, there was only half the C14 in the atmosphere at that time. Well, why is it that when we pull atmospheric bubbles, and as a guy with a doctorate in atmospheric science, he should know this, that we pull samples from Antarctic ice cores that don't have half that amount of C14 in the atmosphere. Why is that? Who knows?
50,000 years old.
50,000, not 100 million years old, but about 50,000 years old.
Okay.
Now, the first thing we had to do was to confirm that this kind of information made sense in the literature. So we went to the literature and got the data, and we plotted it. There was some 70 sets of data that had been reported. We have this all listed in our book that we reported on the RATE project. Here we have the number of samples on the left column, and on the bottom axis we have the percent of carbon-14 in the sample relative to the modern carbon-14. That's a little bit of a complex
Yeah, and I've seen this criticized, highly criticized, because they generally, if they do get a completely clean sample, they kind of will discard it. They'll kind of go, well, that one isn't one of the ones we're going to use. So they've had a lot of criticism with their methodology for doing this. But it's important to understand. The only thing you got to understand is when you are doing C14, you want as large a sample as possible. Actually, when you're doing any kind of statistical analysis, you want a larger sample as possible, right? Because if you've got some microbacteria in the tiny little sample, yeah, it's going to show up. But over a large amount, it's just going to be background noise.
Measure there, but it comes out that the ratio of carbon-14 to carbon-12 is what that second C is there, that it comes out to about 0.3. And so that's about the middle of this diagram here, this histogram. And that's much more than we would have anticipated if the coal is old. This is all for coal. But we went further.
That's hilarious. They blew their budget on CGI molecules, couldn't afford research. I think they can with the amount of money they get. I mean, look at their set and everything. It's so... Like, seriously, if they wanted to go out and do real research, they can afford it. But they don't. If they wanted to publish stuff, they could. But they don't. And that's really where it's at. And then they want to claim conspiracy. There's no conspiracy about it. It's just that you guys are not producing science. You're producing apologetics. And that's the problem.
Further than that, we actually then took samples ourselves. And we didn't have the money to go out and get 70 samples like is reported in the literature, but we wanted just to get a sample. So we went.
No, you do have the money to do that. You just didn't. You took small samples, and that was part of the problem. That's part of the problem. And there was some accusations. I don't know if they're true. But there were scientists saying that in their methodology they discarded samples which had no C14 in them, that they did not take an average of all these samples. They just used the samples with high concentrations of C14, which would not surprise me considering the methodology that I've seen some other creation scientists use. That would not surprise me.
Went to the Pennsylvania State University coal lab and acquired 10 samples of different kinds of coal, all the way from the top of the formation of the crust of the earth to the bottom. There's different layers, so that you would expect them to be older or younger.
Right.
Well, here's a thing. How about you stop creating CGI for carbon molecules? You stop doing these ridiculously expensive looking sets and all of this kind of stuff, and you just do the research, right? Put all of that money into research. Stop doing these frigging productions, right, that are meant to convince people in general out there in the public and your congregation. Stop doing all that nonsense. Just put that money into acquiring the samples that you should do, and then instead of broadcasting it in general to people that do not understand the process, because even I mean, I wouldn't know how to do that. I don't understand the process. All I can tell you is how scientists have reviewed this. Why don't you actually produce a paper and send it in for peer review instead of this song and dance that you're doing to convince people who really don't know how it's done or why there is trace amounts of C14 in it? So they can afford it, it's just they don't. That is absolute nonsense.
This is the kind of samples that we got. Again, we came out with the same diagram, number of samples and the percent of modern carbon, and it came out to about 0.3. Here was about 0.25, somewhere in this neighborhood there. Very close to the larger sample that was reported in the general literature. Now, the significance of this, in addition, was because we had 10 samples of all kinds of coal, it turns out that the distribution is relatively narrow, and it doesn't show any change as a function of depth. In other words, you would expect there to be much less carbon-14 in coal that was down near the bottom, which was much older, and much more in the coal up near the top, which supposedly would be much younger.
Which assumes...
Not really. Bacteria gets everywhere. Like it is, as I said, it's incredibly durable and it kind of gets everywhere. So just because a coal sample is higher in the stratigraphic layer, like it's in a higher strata, doesn't necessarily mean it has less contamination or more contamination, right? Like that isn't necessarily the case. There's a lot of things that will affect how much bacteria or other organisms or whatever gets into it. And one of those is not really depth. It's not really the case. I'm not sure why it should be.
Uniformitarianism that gradually over millions of years these layers were put down.
Exactly, over millions of years.
And that would mean that the lowest ones would have the least carbon, if any, and the upper ones, if there was any carbon, it would be up there.
But they all had the same amount.
It's the same right through, like it all happened all at once.
All at once. That
Yes.
gives you an indication that something dramatic happened very suddenly, all at one time.
Okay.
Okay, well, one of the criticisms for this technique is that...
No. It means that you're reading the contamination from bacteria, and that is about the same everywhere. That's what I mean by background noise, right? Like it's about the same everywhere. That's just how it works. It's wild. It's absolutely wild. No, it doesn't mean that they're all buried at once. It means that you're picking up background noise from contaminated samples.
Possibly the coal has been contaminated. You remember I said all these 70 papers that had been published in the literature said that coal may have been contaminated or their instrumentation had been contaminated. They eliminated the contamination in their instrumentation, but possibly the coal itself. Now, how that could happen is the coal is under the ground, and you could imagine groundwater percolating from the atmosphere. It'd have the carbon-14-12 ratio and going down through and percolating through the coal.
So the water could bring fresh carbon.
Potentially could do that. Now, we selected samples, and so did the...
Yeah, that's not the only way. That is a possibility. I mean, that is a possibility. Water, as I said, is a carbon sink. So, like when we do carbon dating on marine creatures, we have to be aware that there is a lot more carbon in the water. So fish mollusks, fossils like that, we've got to be aware that they may have got extra carbon in them, as opposed to breathing it from the atmosphere. Of course, fish are, breathing in seawater essentially, and getting their oxygen from there. So we just have to be aware of it. That's all.
Traditional community to minimize that, and it's not very likely, but theoretically it could happen. So Dr. John Baumgartner, who conducted this study for us for the RATE project.
Yeah, okay. So John Baumgartner, geophysics and space physics. So he's a physicist. He's not a paleontologist. He's a physicist. Yeah, Baumgartner I don't think is very good at all. Yeah. I think Gutsick Gibbon, Erica, has some not flattering things to say about Baumgartner. Let's see. I didn't look up Baumgartner. PhD, I guess. Well, there's a lot of John Baumgartners around. He is a geophysicist, though, which, that does fall within this sort of, radioactive decay is definitely. Oh, no, he joined Ron Wyatt and Salvage Expert to go to Drupana to find Noah's Ark. Yeah, that's... Baumgartner did not support Wyatt's and Fessel's claim to have a boat-shaped object. He argued the object was natural formation. Well, I mean, he seems pretty legit. Geophysics and space sciences. In 1994, he presented research at a geophysics conference saying that slip-sliding geologic plates that cover the Earth might once have moved 1,000 times faster than they do today. What? I'm sorry. I'm sorry. That is wild. That is wild.
Had an idea.
My part in the RATE project was to coordinate the research on carbon-14. What we found is like a bombshell as far as evolution is concerned. The essence of our work is that carbon-14 exists in all fossils throughout the geological record at levels easily detected by the current technology.
Yeah, that's probably because bacteria exist in all the fossils. All the fossils, yes. They kind of get everywhere.
And what this means is that all of these fossils are young. As far as we know...
No, they're not young. Even if that were true, even if that was not background from contaminants getting into the fossils, and most notably, like he sort of said water, but he completely missed microorganisms, right? They kind of, especially when it's just a piece of earth, they kind of get everywhere. Now, there's not a lot of them. They don't have that much C14, but it's enough to detect with incredibly sensitive instrumentation. We're aware of this. We know about it, okay? We know about it. It's not a problem. It's just a limitation. You've got to filter out that background noise. But, of course they don't want to. But, even if that was background noise was just really the fossils aren't as old as we think they are, it would still place it at 50,000, which is way beyond your guesses at 5,000 to 6,000 years. It still doesn't work.
There may have been one or two attempts in the past to look for C14 in diamond, but the standard community, the secular community, would have no motivation. They would think it would be impossible for there to be C14 in diamonds. All of them we have tested thus far are from Africa, but from different parts of Africa. And we have diamonds both from deep mines and also from surface locations where they have been blasted out of the earth, come down and gotten incorporated into streams and stream beds. So we have diamonds from a deeper earth environment as well as surface environment.
It took them about...
Yeah, so with diamonds, you might go, well, how did microorganisms get into diamonds? They didn't, right? So diamonds do contain some radioactive elements already. I think some uranium. There might be some, I think, thorium in there. Like, they do contain some radioactive elements already. That emits particles which can then transform any nitrogen into C14. Right, because the nuclear chains that are happening when they do alpha or beta emissions, that can then cause other chains, basically. So what they may be detecting is C14 created by the radioactive elements in diamonds emitting some particles. Or it may just be some microorganisms, it may be, but diamonds, because they're crystalline in structure, there's way less chance of that. But that still doesn't mean they are correct. Because don't forget, C14 dating is dating when the organism stopped exchanging C14 with the atmosphere. So when it stopped breathing. You can't apply that to a diamond. So they're basically using it in an incorrect way. Right? Saying, oh, this shows you how old the thing is. Well, no. No, it's showing you when it died. So if you're going, well, the diamond died at this time. No, that's not how you use that methodology. Okay, it's only for organics. And if you're doing it with rock, you're doing it wrong. You're doing it wrong. Because in rock, there may be some other radioactive elements that can create C14. So no, you can't do it with rock. It's not possible. And they're pointing at this limitation and going, oh, it completely makes it useless. No, you're doing it wrong. You shouldn't be doing that. Alpha emissions, is that biblical? I don't know. What particle? One is a throwing off a proton and one is throwing off a neutron. I can't remember which is which. Beta particle is a high energy electron or a positron. Okay. Yeah, and alpha decay? That must be the other one. Two protons and two neutrons. Yeah. Okay, got you. So yeah, these things can happen, but you've got to be aware of it. You would think that a geophysicist would understand this, but apparently not.
2 years to do this experiment. This is kind of an interesting dilemma because they had to crush the diamonds first, and then they had to take the particles, the fine flour from the diamond particles, and vaporize it in an oven in order to be able to run it through their the accelerator mass spectrometer. Well, the problem was these little bitty chunks of diamond, when they would heat them up to several hundreds of degrees, almost 1,000 degrees centigrade, they would explode. And the first time they did, they blew up their oven. And the guy who was doing this experiment for us under contract was so interested in it, he decided to buy him another oven and try again and break them up finer. Finally, he was able to get the diamonds crushed and vaporized and run the experiment. And guess what he found? He found carbon-14 in diamonds. Estimated that the diamonds were on the order of 50,000 years old as well.
And that still means that your date of 5,000 to 10,000 years is absolutely wrong. Absolutely wrong. So it doesn't really help you. But at the same time, look, we know that we've got to account for this sort of background stuff. You have limitations. You can't do it on rocks because they have other processes going on. They're not respirating. Diamonds don't respirate. I know that is news to some, probably all. Diamonds do not breathe. Diamonds are a girl's best friend, but they don't breathe like a girl, okay? Just stop. Why are you doing this? I don't know. Look, if you're saying that you found when the diamond died, I've got serious doubts about your sanity. I really do. I really do. Because all you're showing is when an organism that respirated with the air died. And you can't apply that to diamonds. Diamonds didn't live in the first... What are we doing? What are we doing?
Same as the coal.
Yeah,
Okay.
but diamonds are thought to be 1 billion or more years old. They come from way down in the crust of the earth, and they're thought to be billions of years old, not just 100 million, but 1 billion, 10 times older. And yet they had carbon-14 in them.
Now, the graphs that show them 1 billion years old.
Yeah, so what are you saying? That carbon breathed in the atmosphere and got C14 in it? Because that's what the methodology is based upon. That, hey, I breathe in the atmosphere. The atmosphere has C14 in it, caused by solar rays hitting the nitrogen particles and creating C14. That accumulates in my body. When I die, I no longer will be doing that. So from the decay of the C14 from that point, we can tell when I died. But you're saying, hey, diamonds are doing that. No, what's wrong with these people? I mean, seriously.
Is not based on any scientific evidence. That's based on assumption, isn't it?
It's based on...
Oh, yeah, I didn't even notice that. Yeah, no, 1 billion is not 10 times more than 1 million. Yeah, no, that's not true at all. So 1,000 is the one you're looking for.
a whole idea, a model and so on, it's applied to it,
Right.
but it's not a direct evidence.
Right.
Yeah, it's a model.
That's right. Dr. Vardaman, you just...
Well, yeah, it's a model, and we use it to predict things. Yes, that's what a model is used for. And the thing about it is that when we do cross-check the model with ages like from counting tree rings or doing ice core samples or doing things that, you know, relating it to things where we know the date that that thing died, right, from maybe historical records or something. You know, we know roughly when it died. The C14 is accurate because we can do tests. C14 says it should be this old. We have a, you know, something that this guy or this Egyptian person died in this year kind of thing, because we have the hieroglyphics or whatever that say it, and we date it and it's accurate. We're going, yes, this methodology works. Right? Like, we can test this to see if it works. It's not a problem.
Showed us a chart that, according to what you're reading in coal, was about 50,000 years, and then when you got to diamonds, you had the same thing. Now, you have an animation for us about how that worked with the diamonds. We're anxious to see that.
Right. We found a similar result in diamonds, and this was a complete surprise. We weren't expecting it, but it's incredible.
Yeah, so coal, you might have an argument for coal, right? You might have an argument saying, hey, it was once dead organic material. But I think that the way that coal is cooked by the mantle of the earth would sort of throw that way out. It would absolutely throw it out, as well as all of the microorganisms that it would be exposed to being in the earth. I really don't think that... I think that the best you're going to do is show you with some background noise approximately when the coal was formed. But, you know, everything from beneath the earth, if you take a large enough sample, is going to show some C14, because it gets contaminated by, like, bacteria. It just does.
Here's an animation of what actually happens here. Diamond is the hardest substance known to man. And inside of it was originally carbon-14 and carbon-12, and then with time, it decays just like it would in coal, and it's not contaminated. It's not. Yeah,
I don't think that that's how it works, champ. I don't think that's how it works. I think that carbon is compressed under incredible pressures, and it forms into diamond. I don't think it's out like lying on the surface of the earth and it just picks up the atmosphere. I don't think that's how it works, sir. That is not how it works. I'm sorry.
It's so hard and so compact a capsule that even water running by it is not going to contaminate it. So whatever was incorporated in there was there to start with, and you couldn't add or remove anything. So if there's carbon-14...
Yes, but things can change within the structure itself. So if there is another radioactive element and it's throwing off particles, it can cause carbon to be formed out of the nitrogen by emitting particles. So this is something that can happen. Essentially what happens is the radioactive elements within that diamond act the same as the solar rays knocking I believe it's a proton out of nitrogen and making it into C14. So you can, like, this is why we don't use it for rocks and minerals, because other elements can cause it to be way off. It's just a limitation of the method. It's not a problem. It's just a limitation. We don't use it for rocks. We use other stuff. And this guy pointed out we use other stuff. We use lead, uranium, argon. We use all of these different methods for rocks.
14 in there, you'd expect it to be very young if it's still there. In fact, that's what we found. We found the concentrations of carbon-14 in diamond a little bit less than coal, but it was about the same. It came out to around 30 to 40,000 years old, whereas coal we found to be about 50,000 years old. But the diamonds themselves are conventionally thought to be billions of years old.
So
that's because there's probably particles causing C14 to be created within it, because yeah, there'll be nitrogen trapped inside of it, sure. But that nitrogen, by being hit by a particle, can be changed into C14.
The difference between 30 and 50 is really almost a statistical error at that point. Is that right?
Well, yeah, we think there's some hints there about how they were formed, but we're continuing those studies to try to understand that. But some of our viewers might be confused because I'm saying 30,000 years and 50,000 years. If the flood happened, say, 5,000 years ago, the Genesis flood, how do we get these kind of dates? Well, this comes back to the basic assumption in the carbon-14 technique. You remember at the beginning of the program I said that the basic assumption is that the carbon-14 in the atmosphere has always been the same.
Right.
Well, if the flood really happened, the Genesis flood really happened about 4,000 to 5,000, 6,000 years ago.
It didn't.
Then there would have made a major change in the ratio of carbon-14 to carbon-12.
And if that was the case, our ice core samples from Antarctica would show this change. There is no way that it could not. We have bubbles of atmosphere trapped in ice core samples that we measure, and such a change did not happen.
Because the coal and all the material that's buried in the crust of the earth was organic material that was on the surface of the earth growing in the atmosphere before the flood.
Okay.
So if you measured the ratio of carbon-14 to carbon-12, it was probably 100 times different. There would probably have been 100.
Oh, I'm sorry. Where'd you find this information from? Oh, your ass. Yeah, no, you're just making stuff up now. 100 times greater. Really? Why? We can measure it using ice core samples. We don't have to guess at this.
100 times more carbon-12 in the atmosphere than there is today. So this whole ratio would have been upset by the flood. If you make that adjustment of a factor of something like 10 or so, then you get the 5,000 years instead of the 50,000 years that the conventional estimate comes from. See, the 50,000 years is assuming that the carbon-14-12 ratio is the same now as it was before the flood.
Do you see what he's doing here? All you have to do is assume that it's 10 times the amount that it used to be. Just assume that. That's a lot. My guy, that is a lot. And I don't know how a flood would cause that. Because the C14 is created, right? It is formed, is a better word to use so you don't think it was God coming down and peeing on it or something. It was formed by rays from the sun hitting nitrogen in our atmosphere. Right, so you would have to expect that, the sun was completely blocked out. What happened there? What the hell happened there? How did the flood cause the sun to stop creating C14 at such a rate? It doesn't make any sense. It's wild, right? If you just assume that it's 10 times the amount as before, then it perfectly lines up. Holy crap, that is a wild assumption, my guy.
But if it wasn't, that can be adjusted dramatically.
Well, where are we going to go with this? What's going to happen in this whole debate about, it seems to me the diamonds are one where if I...
It's not a debate. It's not a debate. It is an assertion made by the young Earth creator. It's not a debate. Nobody in sort of geophysics, who is currently working in geophysics or has any understanding of radioactive decay or carbon dating is having a debate over this. Like, what they debate about is how much does this influence it? Can we get it any more accurate? The slight changes in how we interpret the years. Because don't forget, these methods always give a margin of error. And that's important because we can understand there are certain circumstances which can throw it off a bit, right? We know that. It can throw it off a bit. So they will argue over the specifics, but nobody's arguing over, does carbon-14 have, within a margin of error, accuracy? No, that's not a debate. Nobody in the field is debating it. It's just settled science. It's only these guys, and the only reason these guys are debating it is that they have a literal view of the world, literal view of the Bible, and that's their worldview. They think that the history and the past was written exactly how it is in the Bible, and they have to make that true. If this did not conflict with their literal biblical account, they wouldn't care. They would just ignore it. But that's the reason why they say this nonsense.
If you were an evolutionist who wanted to prove that diamonds were still billions of years old, I don't know where I'd start.
Well, in fact, that's kind of the response we've gotten from the conventional community.
Yeah.
As I've mentioned before at a conference.
Oh, they didn't just take your word for it that the carbon in the atmosphere was 10 times different than it was. They just didn't take your word for it. Oh, I'm shocked. I'm shocked that they didn't just take your word for it. Holy crap. Do you want to maybe show that? But, again, they don't publish anything. They publish nothing. So they know that you've got to publish things with a evidence for why the scientists should believe it. And they don't have that. So what they do is they turn to their congregations. They try to convince their congregations and therefore change the scientist's mind through what amounts to a peer pressure campaign or a public pressure campaign. That isn't how science works, my champ. You've got to actually publish it, have it peer reviewed. But they know it's not going to last 2 seconds because there are answers to these questions. Just because you don't like the answer doesn't mean it's not an answer.
We presented these results at specialists in this area were just astounded by that result because this is the first time this result had ever been reported in the conventional literature. And
excuse me, you said it was in the conventional literature. This man said it. This man said directly, we have found this in the literature. Coal has trace amounts of C14 in it. Yeah, that's in the literature. None of this is surprising to people in the field. None of it. It's not, we were unaware there's trace amounts and there is an excessive amount of C14 in diamonds. We know why it's there. It's because C14 can form in rocks when there are other radioactive elements because they cause protons to be knocked out of nitrogen-14. That's not a problem. Like, why? So this isn't news to them. But they're acting like, we discovered this. No, you didn't. No.
It had never been even thought of to do before. In fact, this tells you something about the mindset of a scientist working in the convention.
No. They don't do it because they understand, hey, rocks have changing isotopes in them. We rely on this isotope being taken in through the atmosphere. And, surprisingly, organic creatures don't have enough radioactive materials in them to change nitrogen into carbon. Surprise! Rocks do. It's why no one's doing it on rocks, because they understand what happens.
Scientific community, they assume everything is old and they don't even ask the right questions many times.
Right.
So when we got this result, they couldn't explain it and they were fascinated by it. They encouraged us to continue it, and we understand that there are some people who work in this area that are now doing some of these experiments themselves.
I bet they encourage you to consider it. Yeah, I mean, scientists will say, hey, you got a different result? Keep at it. Provide some evidence Find out why it is there. It's not just enough to say, hey, we believe in a flood. This is why that C14 is there. Because we can do experiments with rocks and show that they can create C14 through the radioactive elements decaying and then the decay throwing off emissions that cause other elements to change and then decay them. We can show this. I don't know. It's wild.
Oh.
It makes the next few years very exciting for you gentlemen, doesn't it?
Oh, it's wonderful.
There's a whole new debate coming.
Yes.
I do want to share this.
The debate never came. I rarely hear this one. I have heard of it. Like C14 is inaccurate, but it's not really this storm that they think it is. There's very easy answers to this, and most of it is just you're doing the methodology of this dating method wrong. You are just doing it wrong. You can't do C14 dating. You can't do carbon dating on rocks. And I mean, carbon dating, they'll usually bring it up for, oh, you know, they carbon dated this thing that was supposed to be millions of years old. Okay, stop. There's your problem. It will sink to a level, and that level will maintain consistency, right? Like a dinosaur bone. Okay, it will go down to a level that is just the background microorganisms, and then it will just stay there. It doesn't mean that, oh, that dinosaur isn't millions of years old because it should be absolutely zero. No, we just know there will be background noise to any sample. That's okay. We can account for it. We can configure for that background noise. It's okay.
Paragraph. I've read a sentence, but I want to share this paragraph with our folks today. This is the closing paragraph from the introduction to the book that is the conclusion of this 8-year study. And it says this: thus this book opens a new...
Buy my DVDs! Yep, and he's selling a book. Of course they are. Because, you know, while they could pump all this money into getting more samples and possibly a more accurate result, instead they've got to produce a book. Because, you know, getting samples and doing real science doesn't give you the money that getting your congregation to buy a book does. Right?
Chapter in the Origins controversy. As never before, it calls into question the deep time model and places the biblically compatible young earth model on a level of scholarship never before achieved or archived. Its pages contain many...
Still not achieved, actually. The book does not put it on an equal level with science, unfortunately. If it did, it might be a fascinating new methodology to be able to you know, find out things, create new medicines and things like that, but it's not.
Profound thoughts, which will shake current scientific orthodoxy to its core. It deserves careful consideration by all of those who value truth.
It really. Oh, okay, see you, Storytime Jesus. Thanks for dropping in, my guy. Really good to see you. Yeah, no, I get you. If you're at a weird time zone, I totally understand. Get some sleep. You know, 4 a.m. Damn. Yeah. So this is sort of it. You know, it didn't shake orthodoxy. The only thing that shook was mainstream scientists' heads when they realized that you were trying to carbon date diamonds and you didn't understand the background levels of C14 within things. That's the only thing that shook. It's just like, this is not a problem. It's a limitation of the method. Like, it's actually baffling.
I think you're listening to this show because you value truth. And I think when you hear this kind of evidence, that many of you who perhaps started the show with a closed mind are ending the show with an open mind, where you're saying, here's evidence that we have to look at. Here are some things that simply can't be explained away by...
Yeah, and the problem with this, when you're appealing to people that are not well versed in science. I mean, I'm not a scientist myself. I would happily admit that. I do not do research as I would see it. Like, you know, a lot of people talk about research, like flat earthers, you know, oh, I've researched everything to do with the earth kind of thing. And it's like, no, when you're talking about research in science, you're really talking about doing, you know, scientific testing in a lab you're really, or you're doing field research kind of thing. You're really doing practical implementable testing for hypotheses and things like that. Like if I say, hey, I researched this movie, I'm using it colloquially. Research is a bit different. So I wouldn't claim to be a scientist, but the reason why you're appealing to your congregation is, and the problem is that congregation then goes out. Maybe they're speaking to a real scientist. Maybe they're speaking to somebody who is has their field in this subject, and they sound like an idiot because what you have armed them with to go up against this scientist who, as far as intellectual ideas go, they have like a nuclear weapon as far as how this works. They have, a machine gun full of ammo. You're giving them a toy hammer, something that is not even a weapon against. They sound like morons because it is so easy to explain that even a dummy like me can understand it. It's not that hard. It's just, these guys keep lying to them. They keep lying to them. Maybe they're lying to themselves. I don't know. But they do not have a smoking gun here. The gun's not even warm. It's not even lukewarm. It is a completely frigid gun. Okay, there is nothing here. It is just, we did this scientific procedure and this scientific testing badly and inaccurately and out of the context in which it should be done, and we got results that show that it didn't work. Yeah, well, no shit. No shit. It's like doing an appendectomy on somebody's tonsils and then going, yeah, we did it in the wrong place, but it didn't fix the problem. What are you talking about? That's stupid. You did it out of not in the area you should be doing it. Of course it didn't work. What is wrong with you?
Billions and billions of years. Perhaps you've been duped. Perhaps you've bought in to the idea that if they say it at school, if it's in the textbook, it has to be true. We put our kids in a real dilemma when we teach.
That is not how things should be taught. What they should be taught is why it is true. Not just that it's true, but how we figured it out. I know that, a lot of the things we learn as adults. We get told it in school, and it takes some investigation. And I do love the community that you guys are curious. I know I am. I will watch videos on how do we know this is true. Sometimes as a kid, you get told how we figured it out, and it's a bit too complicated, or you just don't remember from school. You know what I mean? Like, I must admit there is some things that I look up as an adult and that tells me something and I go, oh yeah, I learned that in school. But, a lot of the creationists, they just tell their people what is true. They don't tell them how they know it's true. Not how, how did we figure out all of this is true? It's just that, well, it's true, assume that first, and then go from there. That is not the way to teach a child anything. Like, it's fine to learn, certain things. It's fine to learn, hey, this is how evolution, works. A big question is, how do we know that? And how do we use that information going forward? We have, for evolution, for virologists, we have people that do medication for things like antibacterials and antivirus stuff. We need to know how we figured it out and that how we implement that knowledge into the future. But these guys don't care. All they care about is that people believe them when they say that the Bible is literally true.
teach them that the Bible says that the earth is just a few thousand years old, and then they go off to school, to high school, and then college, and professors with great authority say the earth is billions and billions of years old. You recognize that if we don't address that issue, we're going to lose our young people, didn't you?
Yes, this is one of the top problems.
And that is right there is why they are doing what they're doing. Because they want to convince young people that science doesn't know anything and we have the real knowledge. Like, there's plenty of religious people doing scientific things. I think that just recently President Sunday did a thing about pushing back. I think not heavily, just Erica Gutsit-Gibbon, who I mentioned earlier, she did a thing about how you can be a scientist and a creationist at the same time. Like, you can compartmentalize those, I think is what she was saying. And President Sunday was pushing back on it, saying, you know, this kind of thinking is antithetical to scientific thinking. But I think there is, you know, people that compartmentalize it. I think that you can be religious and a scientist at the same time. I think that I would imagine it would probably make it a little bit more difficult, you know, I would imagine. But as long as we realize that we can, like when you do classes on science, right? Like when you do, hey, here is the process for how we, you know, take a hypothesis or an observation and then a hypothesis into a theory, into, you know, the set scientific theories that we have. It's not like you'll just say, hey, you're not allowed to bring religion into that. No. That isn't what they sort of saying. What they're saying is only go for empirical observations and empirical results. You're not supposed to bring anything else into it, right? You're not supposed to have any kind of personal influence on it. It is sort of, if you believe in certain things, you know, you have a bias towards this or that, or you have a bias towards, what's a good one? For instance, that, you know, apes did live this amount of time upright, and that isn't proven science. You can't cite that. It's just your personal belief. You're not supposed to bring it into the paper, right? It's not just, well, they're getting religion out. No, they're getting personal biases out, and they've done that forever because that's how it works. And your religion just happens to be a personal bias. So as long as you leave that out, it's fine. It's fine. Well, he also does geophysics. You know, like that is also geophysics, to be fair. But I really think that it's shocking that a geophysicist wouldn't know that C14 can be created by radioactive elements within rocks. That's kind of wild to me.
That we have in our educational system today, because science and scientists have such credibility when they say the earth is billions of years old. It really puts us in a dilemma when the Bible says it's only 6,000 years or so old.
Dr. Vard.
Well, that brings up a good debate and something that we should be aware of when we are dealing with scientific people. Scientists do have a lot of credibility, and I think sometimes too much credibility. You know, there's an argument to be made that a scientist, just because they are a scientist, they sort of get trusted a lot. And there is an argument to be made about, for instance, string theory is a good example. They sort of postulated string theory, and everybody sort of ran with it until, hey, it didn't work and give the results we were expecting. So I think a bit more caution in science is definitely warranted. I think that is good. But that doesn't mean you just throw everything out. It doesn't mean that you just go, well, you know, there's some problems with the way that quantum gravity marries with relativity, so let's just throw all of them out, right? That's not how it works. There should be caution in science. I agree with this guy, but you know, just because you have caution doesn't mean you throw out everything that we have learnt about any given field. It's kind of, and I think that some scientists are taken way too seriously because they are scientists. The ironic part is, irony's in the chat, is that these are the guys, because they're scientists, they get taken way too seriously in their, creation science thing. It should be based upon the results and the peer-reviewed journals that they have contributed to, not them personally. This is the absolute screwed thing about it. He's saying scientists are given too much credibility, and he's a scientist who's being given credibility not for his work but for who he is. And young earth creationist institutes like Answers in Genesis, Creation Institute, all of these things, they do it the worst of anybody, because they don't look at the person's research. They don't look at how much it's peer reviewed. They don't look at whether that matches up with the current science. All they do is just say, hey, you're a geologist and you think the earth is 6,000 years old? Here, say it's 6,000 years old. We've got an expert on our side. Ridiculous. So yeah, I think you really need to start looking at yourselves. Whether you are looking at Dr. What's his name? Dr. Vardiman here, for his work contributing towards the current understanding of C14 dating, or whether you are just using his name to promote your religion. I know which one I would guess it is.
And these 8 warriors that have worked with him in the laboratory have opened up a whole new arena of debate in the whole issue of origins. Dr. Vardiman, I want to again share with you my heart.
Yeah, they opened up a debate and then ran headfirst into the heat problem and fell down, kicked their legs in the air, and then sort of died. Not literally, just metaphorically, the rate project collapsed at that point because they had absolutely nothing. In order to solve the heat problem, they basically would have had to rewrite physics. So they have to appeal to something. Oh, we'll find a solution in the problem, or it was a miracle. That's okay. You want to, prove that scientifically and produce a paper on it, or you want to just claim it? Oh, you're just going to claim it to your congregation so they can pressure the authorities into changing the curriculum? Oh, I see what you're doing. I see what you're doing.
Felt appreciation for your dedication and your courageous work. And folks, I want to remind you that this is not just opinion. This isn't just superstition. This is digging into the truth of science because we believe the truth of God's Word. And what we find there is absolutely astounding and exciting.
This is not science. This is assertions being made by people that don't understand how the process works. If it was science, you would publish and be damned, sir. Publish and be damned. Yeah, no, that is a bit baffling, yes. Yes, absolutely is baffling, I get you. See also Dawkins on computer science. Yeah, no, I would... Look, okay, so I'm a network guy. And by network, I mean, like, computer networks. I do not let anybody touch my network, okay? Not even... My wife can't even touch it, okay? You're not allowed. You're not allowed. It's my network. Get off of it. I would not trust Dawkins to touch my network out of anybody. Absolutely not. Absolutely not. No way. No. No.
And above all, I want you to remember this. It's God's view that He created you. That should be your worldview too. Hope to see you again.
This music is awful. This sounds like, I don't know what, this sounds like a, one of those 80s, like, internet, you've got an AOL, how to use it. Put the disc in the disk drive. That kind of background music.
Next time, here on Origins. God bless you till then.
Okay. Wow, that preaching at the end, though. That preaching of the end, holy crap. Yeah, and that music, like, it really did sound like a 80s AOL instruction video kind of thing, That's what it sounded like to me. But yeah, there are explanations for C14 in diamonds. There's explanations for why we get a background noise of C14 in old fossils. There's always going to be these trace elements, more in diamonds because of just the way rocks work. It's not a problem. It's not a problem. It's just a limitation what we're doing. You know, that is just the reality of things. Things have limitations. Methodologies have steps you have to follow in order for it to work. And if you deviate from that, you're going to get a bad result. And we understand why you will get a bad result. It's not just that you will get it. We understand why you get it. Like I said, it's like when you're weighing something, you've got to tear out the container. Tear, T-A-R-E. It means to reset scales, basically. So, you know, when you put the container on your scales first, you tear it, because if you just don't do that, they're like saying, well, when you just put the container, it doesn't measure the butter correctly. Yeah, you've got to calibrate. Yes. Who would have thunk it? Like, it's not a problem. It's just a limitation. And because there are microorganisms in these fossils, just be aware that there will be some trace elements picked up from those organisms no matter how old it is. That is just the reality of the situation. If you're talking about doing C14 in rocks and diamonds and things like that, it will not work, because C14 is created spontaneously from the radioactive decay of other elements like uranium and polonium and things like that. You know, it's not a problem. It's just a limitation. We can't do C14 dating on inorganic substances. And even if, for some wild thing that we're completely wrong about that, you're still getting 50,000 years, which completely breaks your flood narrative. Ridiculous, right? Why do we get accurate results for something, you know, a couple of thousand years ago? You know, like I said, someone may have written a parchment in, I don't know, someone may have written a parchment in France a couple of thousand years ago on some pig leather or something. I don't know. And we can date that to when we know it was, because they recorded it. So it produces accurate results within a margin of error, and understanding that there are some constraints on the method. But it produces accurate results. We can use tree rings to say, hey, we know this tree died here. We have records saying the tree was chopped down or the forest was chopped down, and it seems to be correct. We can do other things. And their excuse that, we don't know how much C14 was in the atmosphere, we actually do. We have ice core samples that show us exactly the composition of the atmosphere, the bubbles trapped in there for thousands, hundreds of thousands of years. We know. It's not a guess. We know. It's pretty cool. It's pretty cool. But anyway, so that was Fundamentalist Fails. I just do want to give another shout out to, I'm sorry, I've forgotten your name again. I'm so sorry. Matthias ZG, or Matthias Zug, for, I don't know how to pronounce that, but they suggested this one. It is a bit of an older one, but I think it's good to go back over it. And so if you ever get the, did use C14, it's inaccurate. What do you mean by accurate? Did you use the method that that carbon dating, radiocarbon dating, did you use that methodology correctly? Or are you being an ass and going off and trying to carbon date diamond? Did you use it correctly? Or are you just assuming that any carbon-14 means that it can't be millions of years old? Because once it falls to a certain level, it's older than 50,000 years. That's all we know. And that's when it falls to a certain level, not when it falls to zero. Because we always will pick up trace amounts. It's a background noise. That is just the reality of the situation. So those are the questions you should ask when people say, radiocarbon's not accurate. Odds on they're using it wrong. We have validated the accuracy of carbon dating through other means, through other methods. It's not a problem. And it's in a margin of error. Could be out, decades, hundreds of years maybe. Definitely not thousands. Definitely not. And it's pretty damn accurate. That's where we're at. But I hope you've enjoyed that. That was actually a really good video for going over an argument that I think it's sometimes brought up, but it's not really, it isn't the fiery debate that these guys, Dr. Verdeman, was bringing up. It didn't turn into that fiery debate. And that's because, yeah, the scientific literature was already aware of these things. They had already addressed these things. And because these creation scientists aren't reading the literature, they're not reading what people have come out with, they just miss it completely. Either that or they just don't mention that, hey, there's an answer to these things and a very good explanation. Is that dishonest? Maybe. Are some dishonest? Probably. The fact that they were selling a book as well and they won't publish is sort of telling to me. So, but yeah, it was a fascinating to look into this. Did take me a little time because I didn't know all of the arguments. I want to give a big shout out. Matthias, thank you. It was very interesting for me to find out. And hey, being curious is great. Being curious is fantastic. I love figuring stuff out. This was really interesting. And, I have a bit more knowledge than I used to. But, yeah. But thank you so much, everybody. Really appreciate it. Big shout out to everybody out there. I see Tori's in the house as well. Awesome, awesome, awesome. Yeah, thank you so much. Do take care. Now, be kind to yourself. Okay, you're not going to know the answer to every single thing coming out. It's just not possible. This is why we have specialists. Okay, it's why we have scientists. I do not claim to be an expert in C14 at all. I am just relaying to you what more knowledgeable people than me have figured out. This is why we have specialists. But that specialization, it has to be curated in some way. It's got to be overseen. The only way we can do it is those specialists curate among themselves. And it works pretty well, comparatively. It's not perfect, works pretty well. I think this video brought up a few things. We should be critical of just trusting scientists. We should be. We shouldn't just trust them because they're a scientist. We should trust them because the methodology that they're using is supported and it has been proven to be effective. So, but we shouldn't just trust them at all. So be kind to yourself, be kind to each other, and I'll see you in the next one. Bye, everybody. Take care. Hello? Why isn't it switching? It's broken.
To what new horizons can we look now? Where are tomorrow's opportunities? The frontiers of the future are not on any map. But now, what's ahead of us?